Hello, everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre. With me is Z, and we also have CTS as a guest today for some of our discussion topics. So, some of our topics today include a Fuzzed UAF read from Project Zero in Linux, a black box fuzzing post about fuzzing Microsoft Defender, and some discussion around finding bugs and demystifying security research. Due to having CTS on, our order might be a little odd today. We're going to lead off with the discussion and then get into some of the blog posts and more typical topics that we cover. Before any of that, though, as always, Z will get into the Spot the Vuln challenge and solution, which apparently the Spot the Vuln was inspired by my own code. So, bit of a humbling experience.
Fortunately, your code was not like authentication or like really security sensitive. And that's kind of the case with this vulnerability in general. Key issue here, we've got two functions that just like, can you do an unprivileged action? Can you do a privileged action? And what it's doing for this, it's got a bit field that contains a user's privileges, or at least that's the idea, and it just turns 0 or -1. -1 on air, 0 if they can do it. It just checks the bit fields. The way it does that is by creating this expected field for what privileges you need in order to do this. So it checks in the can do unprivileged, it's just going to look for that priv user and then whatever action they're actually wanting to perform, which should match up with these action defines, whatever. It's just looking for these bits. And then it'll return based on privileges the user has, bitwise and expected, and just making sure all of the bits in that are in there by doing equals expected. The problem is the precedence, or basically order of operations. This equals will happen before the bitwise and. So what ends up happening here is this resolves to, is expected equal to expected? Yes, it is. And then it performs off of that Boolean value, or just the one. It'll perform the bitwise and with privileges, so it only ends up looking for this one flag to be set. And that's it. Same logic happens in the priv admin. So as long as the user has this priv user bit set, these will pass. So realistically, you're probably not going to see this exact code. But this sort of issue and the precedence of the bitwise operator does kind of pop up just in doing certain calculations and can have a much more subtle issue pop up because of it. So I figured it was worth at least calling out as something to be aware of. I think Clang will warn on this. I don't think GCC warns on it, though, by default. There's probably something you can do to enable that warning, but it is a little bit silent in that sense.
Yeah, and it leads to a bit more of like a logic type bug, which are always a bit more interesting to cover. So yeah. All right, so some of the offensive con talks went out, and one of them was from Mark Dowd, who's the founder of Azimuth and wrote Art of Software Security Assessment, which we've talked about a little bit before. And he did a keynote on how do you actually find bugs, which we thought would be an interesting launch point for a bit of discussion because it's a super popular question, one that gets asked in Discords a lot, including the Day Zero Discord. And it's one that some of us have some thoughts on and wanted to share. As such, we won't go too much into the talk, though there is some talking points from it that we'll probably bring up and overlap with. But yeah, so we have CTS on for this discussion. So CTS, I'll let you introduce yourself here, and then we'll get into it.
Hi, I'm CTS. I'm a washed-up security researcher, and now I'm a fucking crypto bro. I'm the co-founder of Zelic now, and we do smart contract audits. But before this, I did zero-day research, some Vuln research, and I worked at Dataflow Security. That's about me.
That's got to be the best intro I've ever heard.
By the way, are you allowed to swear on this stream? Is it like a family-friendly thing?
I mean, I just have to mark the podcast as explicit when we upload it.
Oh crap! I've blubbed it.
It doesn't matter a ton to me. It just ruins our metrics, you know.
Oh yeah, I
very few people we get.
I'm terrible. I ruined everything.
It's okay. We forgive you.
But yeah, I mean, with this discussion, I was kind of thinking, yeah, the talk is, you know, how do you actually find bugs? Realistically, it is just about like getting started or just like doing actual vulnerability research. And that's kind of how I want to frame the discussion, is talking just how do you get started? Should you even get started? Out of Dowd's keynote, he made kind of one comment about, learning exploit dev versus the vulnerability research as, you can learn the mechanics of a magic trick, but that gives little insight into being a magician. And I feel like a lot of people kind of fall into that trap of you study all the exploit dev for a while, and it's like you learn all these exploitation techniques, you dig into it, whatever, and then, well, now what? Where do you go from there? And it's kind of like the mechanics of it, but not really how to be a magician in this case. That at least resonates with me because I used to work as a magician professionally before moving into security, and that's also a thing there where you can learn all the sleight of hands, but showmanship and presentation, everything around it also goes into being a magician. But I guess starting off is really the question of, should you learn vulnerability research? There are some cases where perhaps you might get away with just exploit dev. I wouldn't recommend it. I haven't really seen too many jobs that just do exploit dev. That said, you maybe could. I would lean towards saying vulnerability research feeds back into the exploit dev anyhow. As you learn about vulnerabilities, you learn about what can be exploited, and you learn about what's exploitable or not. Learning the vulns, you come up with more subtle bugs that get you to that exploitable state. I think there's a feedback loop going on there, so like it is an important thing. Actually, where the doubt talk starts off is, what defines, or what are some of the defining traits of a security researcher? Which is, for him, curiosity, detail-oriented, and the ability to deal with failure.
Yeah, he seems to talk a good bit about failure and like some of the cases you can end up in where, uh, let's say like you were auditing a subsystem, you didn't find something, and then later on a bug ends up getting patched there. It's not a fun situation to be in. Uh, nobody wants to experience that, but he kind of talks about how you can deal with that a little bit as a researcher and kind of look at it as like um, as a double-edged sword where it's like, okay, yeah, that got patched and you didn't end up finding it, but you could use that as a source of inspiration to maybe find variants or some other similar type of bug. So yeah, I thought that was interesting, particularly on like the handling failure and like the motivation side of things. Another thing he mentioned around that time was something that you've talked about a lot on the show before, which was having like a procrastination project or kind of a backup project you can work on, even if that's just another subsystem of the same target or something. Um, yeah, it seems like motivation is kind of the key factor that he hits on there, and rightfully so. I mean, I would say that's probably the most important factor in VR.
I would say that when I deal with it, I cope with the stresses of VR by crying myself to sleep.
If it works for you, it works. I haven't tried that myself. But realistically, there's a ton of failure in it. I think it's really easy to look at, just the write-ups being presented where everybody's successful. Of course, they found something, they're talking about it. You look at DEF CON, you look at whatever conference talk, it's like, they're finding things, they're always successful. And then it's like, you sit there, it's like, you've maybe spent a week or a month to have like nothing to show for it.
Just 1 month?
Or months. But like you can spend a ton of time and you're constantly failing, and then eventually, hopefully you get something. Maybe not, maybe you have to call it quits and move on. That's where kind of the procrastination project comes in. Just letting it kind of sit in the background. Something I found true for myself a lot is having kind of a second project to work on, just so I'm doing something kind of productive. Or maybe I'm just not being productive at all. But then, you come back to a project and all of a sudden you have these ideas that maybe start working out, maybe not, but your brain kind of works in the background a little bit. I think ultimately, though, obviously, if we're doing this discussion on the point of like, should you even jump into VR? Like, yeah, it's worth doing, and even in today's, the mitigations and stuff coming out, vulnerability research is more than just memory corruption. I think that's another kind of common misconception to kind of see is, I just want to do the low level memory stuff, and applications contain a lot more. There are a lot more issues. You need to be able to find, any sort of issue, not just this memory corruption, although a lot of vulnerabilities do fall into that area.
Yeah,
Go ahead.
actually, I was gonna jump into this a bit here because this might be a good place to bring CTS in to talk a little bit about the crypto space because, yeah, when you're talking about binary, sorry, but yeah, like on the binary side of things, it is pretty much mostly memory corruption. You do have the odd logic issue here and there, but memory corruption is a large part of it. Whereas when you get to like web applications and even like into the crypto space, it's more like typically like logic issues or authentication type issues. Um, so yeah, I was just curious if you had any like um, unique insights on that CTS with like some of the crypto bugs and how comparable that is to memory corruption in like the VR process, I guess.
Okay, that's quite a big question. So I would say that like I think logic bugs require, I guess, kind of like a different mode of thinking in the sense that you have to be very cognizant of what the intended design is, or perhaps not just the intended design, but what the developer wants. A lot of the time when we're auditing in, for example, smart contracts, one thing that we see a lot is that the code does what is intended, but it's not what the developer wants. And that's ultimately the problem. I think that when you're poking for, let's say memory corruption, right? I think it's very cut and dry when there is a vulnerability or not a vulnerability. It's like, okay, this is a double free. Like this is, out of bounds, right? It's very obvious that it's a bug once you see the bug. Whereas a lot of times with logical mistakes, the code can seem totally fine until you think about the context of the system as a whole, I guess. So I think it definitely requires putting on a different hat. You still have like the same mentality, which is like, oh, I'm going to go in this thing and I'm going to poke holes in it. It's kind of like the attitude you go in. It's like, okay, how can I mess with this? Like, what can go wrong? Like, what if I do this, this, and this? Will it behave poorly if I, do some weird stuff to it? I guess.
And I mean, a lot of vulnerabilities kind of end up just being that, you kind of know what the developer's thinking, as you just said. And this doesn't quite match up with either your expectation or what the developer wanted. And then you can launch off of that into, well, how does that become a vulnerability? Or even is it a security issue at all? Is it just a bug? Or how can you kind of, I guess, pivot into something more security related? But you kind of need to be aware of the whole system and the intended system, yeah.
Yeah, could you clarify exactly like what the question is here? I'm sorry. It's just kind of late over here.
Oh, well, yeah. I wasn't, or go ahead, Spectre.
Yeah, I was just gonna say, I mean, that basically covers what I was intending with that question. Just talking about
cool.
kind of the differences between logic issues and memory corruption and the mindset that you have to have when you're looking for those different types of issues.
Yeah, I mean, ultimately, sorry, please go on.
I was just going to say, like, with memory corruption, logic issues, ultimately, like, you do have at least some similar mindset, and you need to understand the core system. It is a little bit more obvious with the memory corruption when it happens, as CTS mentioned, but you also kind of end up in a place where if you don't understand what the code's intending to do, you can still end up in areas where maybe it's not memory corruption, but you still have issues. Like you need to be looking for both types at any moment, not just memory corruption, I guess.
Yeah, and of course, I mean, like one can lead to the other, right? Like you can have a memory corruption that ultimately leads to a logical bug, and that's what, is the trigger that you really want. Or you have a logical bug that leads to a memory corruption, like let's say, due to a logical bug, you're able to double decrement ref count, right? And also touching back on just the broader question as a whole, like how do you actually find bugs? I think one thing that's really important that I believe that Mark Dowd talked about in his keynote, in short, a lot of the difference between being, knowing a few magic tricks and being a magician is the soft knowledge, right? It's the showmanship. It's knowing how to basically contextualize all of your tricks in like the broader environment of like being a magician, right? More concretely, what I'm trying to say is like you can know how to find UAFs or spot a Stack Overflow or whatever, and then like exploit that in a CTF. But I think that part of being a really good vulnerability researcher and actually finding bugs is a lot of soft knowledge. For example, it's kind of like knowing what people are working on and realizing that your research does not occur in a vacuum, so to speak, as in it's basically just being like terminally online and reading like 100 blog posts a day and realizing what's a hot topic, what people are thinking about, because that's a huge advantage when it comes to research. Additionally, like I think that kind of soft knowledge also comes down to knowing which bugs and which targets are lucrative and which ones are not. Essentially, as a researcher, one of your main skills needs to be time management, right? Because ultimately, if you look at any piece of code for long enough, you're going to find bugs in it probably. The question is where should I be looking for bugs, right? Which bugs are the most important ones? And that also comes down to, I guess, the economics of the offensive security industry as a whole. And I guess knowing about the marketplace for bugs, that's extremely important as a researcher.
Yeah, I think I'm gonna pivot slightly just towards one of the first questions I think anybody, if you're wanting to get started with the VR, is how do you choose like your first project? How do you choose a project to focus on? And you hit on kind of a key point there is, what's the business, or what's like the business payoff? What's the purpose behind actually doing it? I mean, maybe you're not doing it for business or for profit. Maybe you're just trying to learn. And I will shout out, we did a prior discussion video about, I think it was in our series about going from CTFs to like real world exploit dev. And in that, I argue towards learning to do the manual auditing, learning to do some VR to feed back into that. And in that, I kind of talk about choosing or Spectre and I both end up talking about kind of choosing the first project. So I'll shout out that, but in general for that, like the summary of it, my 3 points were just, what are you actually interested in? If you have a kind of natural interest in something, it's a lot easier to start digging in and doing a lot of the background research. I would argue, like for a first project, I'd argue towards open source, unless you're really driven, getting practice doing vulnerability research and looking for bugs is its own skill. It's just easier if you start off open source code, random GitHub project even, not doing reverse engineering, it's just adding an extra layer over there. If you're really motivated, fine, whatever, but, and the other point to have is just some that's not super picked over, but that was for kind of your first project. On a serious project, CTS just kind of hit on there, like that business payoff, like what are people actually interested in exploits for? I mean, maybe you want to get some publicity out of it. Is there business interest in securing a particular type of software so that the company can use it or something? And just what are the current hot topics?
Yeah. And also I would say like I think that's also very important to realize like which bugs are lucrative or not. Because at the end of the day, like people measure how much they care about security research basically through money, either directly or indirectly. I think that the kind of bugs that get the most retweets on Twitter, right, are usually highly correlated with the kind of bugs that are lucrative and vice versa. So I think that if you want to be a good security researcher, you have to realize what people are willing to pay you to do. At the end of the day, if you want to farm clout on Twitter, you need to understand which bugs are sellable.
Yeah,
and the bugs that are sellable are usually the ones that are like the most, important or scary, I guess. Yeah, sorry.
Yeah, well, I was just going to say, like, sellable, there is this huge, I think, just general misunderstanding over what vulnerabilities are actually worth. Like, just the idea of every time you see somebody find, like, a random, I don't know, reflected file download in Google, and then somebody's like, I found this vuln in Google, and like, oh, you can sell that on the black market for millions of dollars. And kind of a misunderstanding over the actual value of what the exploits are. So kind of being real, I guess, about that and not just going with, what everybody else kind of thinks it would be. That said, I guess there is some value in what people just think is worthwhile versus what might actually be. I mean, being able to say you have something in Google does kind of add something. Yeah, I don't know. On that point in particular, I guess there is a little bit of value just in the retweetability of something from that perspective, but yeah, I guess sorry, go ahead.
I mean, of course, the market is not fully efficient. It may be that people are more interested in a bug that may not necessarily be lucrative, but keep in mind that people's interest is, a very multifaceted type of thing. I would say that it all comes down to marketing, being able to market your research. That's probably one of the most important skills as a researcher. I would say that time management and marketing are the most important skills for any researcher, academia, Vuln research, no matter what. Yeah, this was drilled into me when I was, in academia. It's like, it doesn't matter how cool your research topic is. If it's not sellable, don't waste your time on it. And yeah, I think that, like, for example, even a worthless bug in Chrome that's, not very sellable, it could still be very good for your career because it's like that bug, because it's in Chrome and that's like a name brand target, because of the like association with a name brand target, the proximity to it, then that makes it a worthwhile or interesting bug, right? From just a purely, I guess, min-maxing nihilistic perspective.
Yeah,
But I think that, like, if you want to have a good security researcher career, like, you need to know how to play the game, right? If you want the InfoSec name, you got to play the InfoSec game.
fair enough. And actually, I don't think you mentioned during the intro that you were through academia, but you were what, at Georgia Tech, if I remember correctly?
Yeah. I was at SS Lab.
Yeah. Okay. So a bit different background than like what I or even Spectre have kind of gone through.
Yeah, we definitely don't have an academic background.
I didn't have to sell any paper, or well, get funding or whatever approved for papers or anything.
Well, I mean, I thank God I didn't have to write any grants because I'm not like a PI or a postdoc.
Okay. But still, you make a good point about like the marketability of what you find. At the end of the day, a CV in Chrome is a CV in Chrome.
Yeah.
As somebody digs into it, they might judge that differently, but it does matter. So those big name targets, I think, are worth looking at. And Dowd in his post kind of calls out a few things like just kind of some biases that researchers might have when they go. And I think a lot of these would pop up with big name targets is everybody's already looked at this, so what hope do I have of finding anything?
Mm-hmm.
It's very easy to fall into that mindset. I've done it myself.
I think a lot of like junior researchers definitely have that trap. I do that a lot too. It's like, well, I don't know, this surface is fucked because everyone's looking at it now, and that's not true because it's like, who cares? The fact that everyone's looking at it is because there's probably bugs in it. So usually the bugginess of a surface is like pretty correlated with like how many people are looking at it, right? So plenty of stuff to go around for everyone.
So I guess this kind of segues nicely into moving on from choosing a project, like let's say, a browser or whatever, and moving more into like subsystem choice. It's like, okay, you've got this monolithic project you're looking at, like a kernel or a browser. That in itself is going to be potentially like millions of lines of code. So where do you focus your attention most efficiently? Because like you were saying, time management is kind of important there.
Right.
And I feel like that idea of keeping in mind how picked over an attack surface might be is a good thing to keep in mind. Even don't let it kill your motivation entirely, but you probably might, or it probably would be a good idea to factor into your strategy trying to look for a subsystem that isn't being picked over as much and is maybe kind of like a hidden gem for security.
Yeah, I think it really comes down to like I said again, soft knowledge. For example, soft knowledge here that's crucial is knowing what's worked in the past, right? Just like being able to do pattern recognition. It's like, oh, like I know that async IO in the kernel usually leads to funky shit, and then I know that IO rering is an active development, and I know that it's async IO. So that's like, boom, pattern recognition brain goes burr, right? And then wasn't it PQL who found the IO ring bug?
Yeah, him and a friend, yeah.
Yeah. Those two. And I think that's kind of one strategy you can take to narrow down what subsystem you want to be looking at. I also like one thing that from the Mark Dowd talk I thought was really funny is the strategy of like looking at bad committers. I think it's really funny that there's probably like a Telegram bot out there, like a Slack bot out there somewhere that's just literally alerts whenever somebody makes a commit to the Linux kernel because they're like making UAFs a renewable resource or something. I don't know.
Oh yeah, so
I
you
would
mean
believe
somebody
it.
who, yeah, you mean like a developer that often commits issues that have to be fixed or something, like doing some metadata analysis at that level.
Yeah,
Yeah, and that's again like soft knowledge, right? Yeah.
I thought that was funny how what Dowd said too was we called like, it's maybe a little bit mean, but some people follow specific devs and consider their or double check their work because of that. And that's completely a viable way of looking at it. I think a big thing is also, if you're just looking at a plain code base, not looking at the external information, which you should be also, but the complexity of the code and the actual reachable attack surface of the code. Spectre kind of hit on those non-obvious areas. Those non-obvious entry points into like creating a new attack service are usually pretty juicy for bugs because they're non-obvious. They're one, they take a little bit more knowledge to find and like be aware of. Um, of course, if it's non-obvious, you're going to have to do that extra work, but less people are going to have picked over it at that point. And if you have the complexity in there, like those two aspects kind of work together. Your attack surface and your complexity to kind of find the right areas. As you're tying in with the committers and all of that, actively developed code is often actively introducing new bugs.
I love code churn.
Old code can have bugs too, and they can have long-lived bugs. So there is kind of a trade-off between old code and actively developed code, because actively developed can also fix your bug without anybody knowing it.
Oh yeah.
So I mean, it's worth being aware of, how active is something, because that is going to have an impact, and that can also have an impact on how you actually approach the vulnerability research itself. You're going to be looking at the commits versus, if something's a bit more static, those diffs probably don't matter quite as much. Or they might matter a lot if it's a very rare thing to change that code.
Yeah.
Another thing I'll throw in there on the like age of the subsystem or the age of the code that was written is favoring more towards the older side. It's worth being aware of some of the newer attack classes or bug classes that have popped up since then. When you're looking at some of these old code bases, like let's say the Linux kernel, just to keep it kind of consistent with some of the previous examples, with IO Uring, like the Linux kernel is like what 30 years old code base or maybe more. I don't remember exactly when it first started being developed, but like you have code in the kernel that was written before some of these other bug classes like race conditions were even really being thought about that much. So looking at kind of how active a subsystem it is, you can kind of run into a situation like that where the code was written without even keeping those attack vectors in mind. And then on the other side of things, like Z was saying, like there's new code that can introduce bugs too. I think it's easy to get into the mindset of thinking that new code is automatically going to be written to be more secure. That you're only really going to find bugs in old code, but there's various examples that are proving that that's not the case. IOU Ring is one of them. So
yeah, and especially if you have multiple developers all working on the same subsystem, they can be working under different assumptions. So kind of being aware of what one person's writing and then comparing that with the consistency of somebody else's code. They might have different assumptions about what's there, or like what's true or not in the environment or in the subsystem. So I'd say like activity is actually a big thing for me. I do like hunting on newer, fresher code. Um, like I said, I find a lot of times it's new code is newly introduced vulnerabilities.
Yep.
I
also. Sorry,
go ahead,
Spectre.
I was going to
Okay.
transition to the next thing, so yeah, you can go ahead and finish up your thought there.
All right, yeah, sure. I'll just wrap up then. I think that finding good bugs, a lot of it comes down to finding good surface, because having good surface is usually like the number one thing for finding bugs, in my opinion. Just like knowing where to look, right? I think that what was I gonna say? Yeah, I think that's a good way to wrap it up. We can just leave it at that.
Well, there was one other point I was going to transition into, which Z was talking about a little bit there, which is the idea of like testing assumptions and note taking. That is one thing that I feel like isn't talked about very much, even though it seems like a pretty important part of the process, at least for me personally. Is it's very useful and avoids wasting time when you take down note of like code that you've already looked at, some of the thoughts that you had on that code, and just verifying the assumptions that were made by the developers. Because if you want to revisit that code in the future, which you probably will, or if you take a break and want to come back to it, just being able to refer back to your own notes is a very useful tool to have available to you. So yeah, that's something that Mark Dowd talks about a little bit here is the note taking, and I think the next post, which we'll talk about in a minute here too,
Yeah,
talks about it as well.
post gets, I think, more into the note taking aspect.
Yeah. But I did want to call that out because it is a very useful tool that I think is overlooked a lot. So since Z brought it up, I guess we'll get into the follow up kind of post that was made by Alex Plaskett. This was inspired by Dowd's talk. And it gets into some of the stuff that we've talked about, but it also expands a little bit on some of the other points, like the note taking. Z, I didn't know if you had anything you wanted to call out specifically here, but mostly we just wanted to give this a shout out because there's some good tips in here as well for Vuln research.
Yeah, some of the things I've already brought up kind of tie in there. I did also want to actually have a bit more of a discussion on like actually doing the VR. Not so much like super specific techniques, but just at a high level. Which is actually, so Alex Plaskett is planning to do 2 posts. His second post is going to be, I guess, a bit more on that aspect. But Dowd kind of talks about it, and Dowd's saying actually, he made a comment that genuinely surprised me, and is actually something I might try for myself. Just when it comes to an approach on actually, so you've chosen a component, or you've chosen a project, you've got that subsystem, and like, how do you actually go into like your Vuln research campaign? Kind of at a high level thing, first step is understanding the project and those components. How does this component fit into something? And then I'd usually say once you've done that, decide on your plan of attack. Maybe fuzzing is going to be viable. Maybe you want to look at the bug patterns, or kind of bug patterns leading to some of the older bugs. So looking at the history, older things there. If you can get automation going really early, dumb fuzzing, just get it going. That way your manual research can kind of feed back into your fuzzer. Sorry, I want to tie this over with kind of what Dowd brought up, was this idea of I would usually start off on a new project also by reading like all the documentation, everything about what they're trying to accomplish, what are the common problems, and having that understanding. And he brings up this idea of, or he would actually avoid reading documentation about like the protocol or whatever until he had already read the code. And kind of come to some understanding of the code, and then look at the documentation to kind of avoid those biases or just skipping over areas, looking at it as kind of having the assumptions over how it's going to work because that's what the protocol says, or that's what the spec says, documentation says this, and just kind of avoiding it. So it's kind of backwards to how I would have normally done it. So I at least want to call that aspect out.
Yeah, I thought that was a bit of an interesting approach as well. And it totally makes sense when you like break it down, but yeah, it's not something I'd really considered before.
Yeah, and I guess I just mentioned about fuzzing and such. Part of the whole process, like, yes, fuzzing tools, so static analysis, stats, all whatever static analysis you want to do, like, it's part of the work. But I think, a lot of people do end up relying too much on tools. Like, you learn the exploit dev. So often I see, is that next, what do you do next if you want to start finding bugs? Well, run a fuzzer. And I really hate that advice, like, on a personal level. Not because running a fuzzer is a bad idea to find bugs, because it's not. Like, fuzzing is absolutely going to be part of a VR campaign. But at the same time, for your next step, learn to do the VR manually. Like, learn to look at the code, understand the code, get in the head of the developers, and get good at reading code first. Running a fuzzer doesn't have to be super complicated, so it's an easier skill to learn. That said, there is a ton to fuzzing, so I don't want to underplay fuzzing at all, because it is a complex field. We've actually had a separate discussion about learning fuzzing. There is a ton to that, so I'm not trying to downplay it. when you get into the depth, but kind of at the superficial level. It's easy to get started with, and so I feel like it's better to spend your time on learning to do things manually and actually auditing code and reading code and just getting practice with that and practice digging into everything, because that's also going to matter for the exploitation.
I mean, you'll kind of have to do that upfront work anyway, because okay, let's say you want to run up a fuzzer on something, you have to know like, okay, what can I target? What attack surface is even hittable? You kind of have to be thinking about your attack vectors and stuff before you even start a viable fuzzing campaign anyway. So yeah, reading the code is a good skill and will be necessary for doing effective fuzzing anyway, in my opinion.
Yeah, like a
Um,
full fuzzing campaign is going to take that knowledge and that effort anyhow. So it kind of feeds back into it. Yeah, like I keep mentioning this idea of feedback loop, but yeah, for fuzzing, I mean, the manual research helps target the fuzzer. Fuzzing results help target where you're going to do some manual research, or can potentially do so at least.
yeah. So overall, I mean, I'd recommend the Dowd talk and this post by Alex Pliskett for anyone who's interested in like VR and has been kind of asking these questions about kind of getting into it and some of the processes there. There's some super useful tips there that I think I'm gonna like take to heart as well. Like what Z mentioned with, trying to read the code and understand the system before reading the documentation. That's kind of a smart way of going about it. So there's definitely a lot you can take away from both the post and the talk. Um, but yeah, do you guys have any last minute thoughts you want to get in there, or do we want to move on to topics?
I will also wrap up actually by commenting on the notes, which kind of led us all into this. Documenting your failures, I think, is really important. Being able to look back and actually take note of why something failed, because you might find code that is, they were saved by the bell. There was an issue, but there's this last little thing that they probably weren't even aware of that made it just a non-issue. That might change in the future. So actually isolating what your failures were, how close they came to a vulnerability, is really useful. Um, Personally, I now use Obsidian for my notes. I used to run like a little Doku wiki and stuff for it. I don't know what you guys do for your notes, but that's always something that, and I don't think we want to go into a discussion of actually how to keep notes. That is getting a little bit off topic, but taking notes, even of your failures, your rabbit holes that maybe you waste. Well, you didn't waste hours, but maybe you spent hours down a rabbit hole. Documenting that so you can get back to it, super important for, like, even in the future on other projects. You never know where that information might help you out. Issues in one project, the problems that one project faces, problems they try and solve, are going to be done on other projects. Which does remind me of one other thing that I actually want to add on, or should have mentioned quite a bit earlier, which is another approach to choosing targets, like a project start, is choosing to focus on a protocol, on a file format to start with, and just learn that protocol really well, and then look at different implementations of it. That's similar. There was a Project Zero post about WebRTC, where Natalie just dug into WebRTC, how it worked, and then looked at several implementations and found all of these issues across how they didn't quite follow or didn't have an appropriate state machine logic. So that's just another approach, choosing projects that should have come up earlier, but that's my long kind of closing notes on it.
ASN1 is another thing you could probably look at, something else we've seen recently from Project Zero. That seems to be a really complex format to handle, but yeah, I mean that's a totally valid way of doing it too, just looking at like implementation type issues. CTS, did you have any final thoughts you wanted to talk about before we move into black box fuzzing? Oh,
I
I
will
think he might
assume
be
that he's
muted.
gone to sleep.
He might have. Okay. Yeah, he does have a bit of a busy schedule, so he might have had to jump out. But yeah, I think that's pretty much wraps up most of our thoughts on the Mark Dowd talk and the security research. But like I said, if any of that sounded interesting to you, you should probably check them out. And just in general, check out some of the offensive con talks because it's a good conference. Usually has good talks every year. So
Yeah.
All right, so we'll get into our first like typical topic, I guess, we cover, which is from Sentinel Labs. And this is about fuzzing Microsoft Defender for IoT and a vuln they discovered there. Now, this is a bit of a long post that talks about the specifics of Defender for IoT, specifically the deep packet inspection or DPI component of it for analyzing network traffic. What's relevant for what they're targeting is these network protocol parsers that get loaded. I think they're called dissectors. And basically, what they're trying to fuzz here is these dissector libraries that can be loaded in to target a specific protocol or whatever. Now, since they don't have the source for those dissector libraries, they had to do black box fuzzing using binary only instrumentation. There was some public resources from Microsoft about dissectors and like the general structure of them, but the information was pretty limited. Um, the setup they went with was using E9 AFL, which was an open source binary instrumentation project built on top of E9 patch, which I wasn't really aware of that project, so that was kind of a cool show from this post. And then they talk about the AFL fuzzing harness they wrote and some of the process there, which I won't go into because it's really specific. Um, Another problem that they had to kind of overcome was optimizing the fuzzer and improving performance, because basically how the deep packet inspection was working and communicating with Horizon, you couldn't run more than one fuzzing instance per machine because there was sockets that would be tied up. Um, they had two ways around that. First of all, they tried closing the existing sockets before forking, but the more elegant solution they came up with was just eliminating the need to send packets to Horizon in the first place, which was by using this other offline mode that was available and analyzing the PCAPs instead of analyzing live traffic. Toward the end of the post, they detail a vulnerability they found, which was a buffer overflow in libsnmp. Fairly easy bug. This process var bind list function would call this other function object identifier get args, and then it would loop using its return value as like a size or a loop counter, I believe. They kind of have the disassembly towards the bottom of the post. I'm just trying to bring it up for those who are watching. Yeah, it's an image, unfortunately, so it doesn't come through super clearly, at least not for me. But yeah, you can kind of see that in the disassembly, they call this getArgs function and check if it's non-zero before doing this loop, implying they expect 0 to be a fail condition. The problem is one particular fail condition you could trigger with a malformed packet would make the function return -1, which ends up running that loop and overflowing the buffer. Mainly, though, why I thought this post was cool was the black box angle of it and the binary instrumentation, because it's just kind of a tough problem to be in, and I think some of that info could be useful to others who might be doing black box fuzzing. So, um, yeah, black box fuzzing has always just been a little bit interesting, especially when it comes to the instrumentation side of things. Binary level instrumentation is an interesting topic that there's kind of ongoing research for, because obviously, in a lot of cases, especially on Microsoft targets, you just can't compile the source code because you don't have it. So
Yeah, and
yeah,
there are a few other options when it comes to the instrumentation. They chose one here. I don't think they really get into their logic behind why they chose that instrumentation versus others, but I agree with you. The more interesting part of this wasn't so much the vulnerability, it was just the fuzzing setup and walking through that.
yeah. All right, so for our last topic, we have a report from Project Zero about a bug in Fuse. That's file system and user space for Linux. And I'll let Z get into this one.
Yeah, and the core issue here confused me a little bit, but partially that was just like my own fault. Core issue is, well, I'll talk through it here. The one paragraph kind of gets it reasonably well. Well, the few paragraphs. It does take other details. But for Fuse, user space file system, key thing here is that when using the fopen direct.io, so this is as you're actually opening whatever, give it in this flag. That's going to mean that Fuse will directly handle like the reading and writing rather than having it go through like the normal kernel page cache. So what that ends up doing, or where the problem comes, is that ends up meaning that the Fuse process, when internal Linux function ends up calling get pages, it just grabs a reference to the user space pages for like the write buffer that it needs to put what it reads into. or right, like with the right buffer, ends up grabbing just the reference to them rather than actually copying those out. So what ends up happening there is Fuse can basically maintain access to those pages. It gets mapped in those pages of memory that belong to some other processor, might contain memory. So after the write happens, write gets completed, those get freed. It can get reused as something or somewhere else. And then Fuse, the user space program, if it's malicious, could actually retain access and read what comes in there afterwards, which they end up abusing with a SecUid program. They use sudo in particular to leak out Etsy shadow hashes. And the actual technique for that, they took advantage of a quirk in libc, and then basically got an error printed that would have this excess information. We're able to kind of take advantage of that. Main issue though is just that shared reference, and not being able to control the lifetime, which is what they call out in the actual patch for this one, was just they can't control the lifetime of these buffers, so just make a copy of it rather than giving the reference over to Fuse.
Yeah, getting into that set UID strategy a little bit there for leaking the Etsy shadow hashes. Basically, what they did was they combined the fact that they could leak that buffer um, with that previous quirk that Z mentioned. Basically, with that quirk, they were able to leak a process's stack contents through messing with the LD debug environment variable, which when you set it to like a non-valid value, it would print like an error message, and it would end up copying that stack data. Um, so yeah, basically you could get the stack data that gets copied out kind of poisoned with the UAF data, with the backing page. How they abuse that with the set UID binary was they basically abuse the fact that sudo will spill the YMM register contents, which is used in memmove for for optimization reasons. It'll spill those registers to the stack when a signal is received by sudo. So I think the signal they call out here is like a sig alarm. So if they can time it just right, they can end up getting the hash contents as they're getting moved spilled to the stack, and then leak that stack contents to leak the shadow hashes. They couldn't leak the full hash all in one shot, I believe. They kind of leaked it in bits and pieces, but even that is a pretty significant thing to POC. So yeah, but I wanted to call that out because I thought that was a bit of a cool trick with how they actually took advantage of the set UID binary to leak the shadow hashes.
It's a cool trick. It did take a little bit of or it is a little bit specific, like you may not be able to abuse that specifically elsewhere. But I mean, as a trick, I mean, it's one of those things where understanding the whole system helps you find those places where you have this one bug. How do you turn it into something actually useful? So
yeah,
I thought it was an
really better
interesting.
at that than P0.
Yeah, I'll be honest. I had a little bit of trouble understanding this post and had to go back over it a couple times to kind of get what's going on. But they write these as reports to the developer, so it makes sense that as someone unfamiliar, I struggled a little.
Yeah, it's not really targeted for us.
Yeah. But yeah, still cool technique for actually getting the data out, and kind of an interesting bug case.
Yeah, for sure. It's one of those more logical. Well, it is a memory corruption, but it's a little bit more involved, and how they take advantage of it isn't super intuitive, and requires keeping a bit of the context of the program in mind. So yeah, cool bug. But yeah, that's basically everything that we have for this episode. So Z, unless you have any last minute thoughts to add in, we'll go ahead and wrap it up.
Nope, and no shout outs this week. Well, besides the random talks that we brought up during the first discussion.
All right, cool. So that's everything we have. Thank you, everyone who tuned in. Also, thanks to CTS for coming on for some of that discussion. It's always nice to get guests on here when we can. So yeah, once again, thanks to him. You can follow him on Twitter. I believe his Twitter handle is
it's GF256.
GF_256.
Yes, so. And Based God something on. I've got the links here. I'll actually put them in chat or bring them up. Just give me a quick second.
Yeah, and we'll have them on the website too. But yeah, once again, thanks to him for joining us. The VOD will be up on YouTube and Spotify and
Sorry,
other
I'm an
platforms
ad
tomorrow. Feel free to follow our Twitter and join our Discord to join the community. And other than that, we'll see you next week.